Hi everyone. Today we're going to talk about two important exponent rules, the power to a power rule and the quotient rule. First of all, please start off by writing this title in your notes at the top of your notes page. For our first example, we're going to look at the problem 4 squared to the third power. We'll be applying the power to a power rule, and it's called that because we have an exponent that's being applied to a term that also has another exponent. Okay, we know that this means that we really have 4 squared multiplied by itself 3 times. We also know that 4 squared means 4 times 4. What we really have here are 6 factors of 4 that are being multiplied together, which we know we can write as 4 to the 6th power. But is there a shortcut? Now, if I'm asking that question, you probably already know that the answer is yes, there is a shortcut. So I'm wondering if you notice any kind of a pattern between what we started off with our original problem and what our answer turned out to be. Hopefully you're noticing that 2 times 3 gives us 6. So for our original problem, 4 squared to the third power, we can multiply our exponents and get 4 to the 6th power. Let's take a look at a second example. Please write this example in your notes. Now, something to note that's a little different about this problem from the last one is that we have 2 terms in the parentheses. Our -3 is our first term, and m to the 4th is our second term. What you need to remember is that the exponent 3 that's on the outside of the parentheses here will apply to all terms inside of the parentheses. So that means I'm really going to have -3 to the third power times m to the 4th to the third power. Okay, -3 to the third power means -3 times -3 times -3, and that will give me -27. If I apply my shortcut, m to the 4th to the third power means I will need to do m to the 4 times 3, which will give me m to the 12th power. And that is about all I can do with that problem. All right, let's make sure that we keep track of this rule because there will be other rules as we go through this unit. So let's put this rule in our notes. We're going to call this rule the power to a power rule. And what we need to remember is that to simplify a power to a power, we keep the base number the same and multiply the exponents. I would also write down this asterisk point. The exponent that is on the outside of the parentheses applies to all the terms on the inside of the parentheses. That's really important, so please write that in your notes. If you need to press pause to get that written down, please do so at this time. For this next example, we're going to switch gears a little bit and start talking about quotients. This example, which you should write in your notes, says 5 to the 6th power divided by 5 to the 4th power. Now what that really means is I have 5 times 5 times 5 times 5 times 5. I think I said 6 5s right there. I should have 6 factors of 5, all being divided by 4 factors of 5, because that's what 5 to the 4th power means. Now the way I've written this problem, breaking it into factors, allows me to cancel out common factors from the numerator and denominator. So in other words, this factor of 5 can cancel out this factor of 5. These two can cancel each other out. These two can cancel each other out. These two can cancel each other out. And what we're left with is 2 factors of 5 over nothing is left. But we always, always, always have a factor of 1. Even when all of our factors cancel out, we always have a factor of 1 for our denominator. Another way of simplifying my answer would be to write this as 25 over 1, or simply 25. Okay, again, I'm going to ask, do we see a shortcut that we could use rather than writing out all of our factors and canceling out the common ones and seeing what we have left? So if we take a look at what we started with, 5 to the 6th power divided by 5 to the 4th power, and looking at what our final answer was, 5 to the 2nd power. Do you see a pattern or a shortcut we could apply here? Hopefully you're noticing that if we take 6 minus 4, we get an exponent of 2. In other words, I can solve this problem by keeping my same base number, subtracting my exponents to get 5 squared. Please write down example number 4, and I'm just going to give you a heads up. Sometimes this is a tricky one, so please make sure you write this one down and pay close attention. When we look at this problem, if we think about our rules, all of our rules have worked when we have the same base number. Now, the base numbers in this problem are similar, but not exactly the same. Can anybody think of a way we could get those base numbers to be the same? We could do it like this. -1 times 9 to the 5th power, which will still be equal to -9 to the 5th power. We haven't changed anything, we just rewrote it in a different way. Divided by 9 squared. Now, I can apply the quotient rule that we just talked about now, because I now have the same bases right here. So I'm going to rewrite my problem as -1 times 9 to the 5 minus 2. I'm applying that rule where I'm subtracting my exponents, which will give me -1 times 9 to the 3rd power. Let's take a look at one final example. I'll call this one the Mac Daddy for today. Looks the most complicated. We have a lot going on in this example. Please write this down. With a problem like this, I like to divide and conquer. Divide not just because it's a division problem, but to separate into categories. I can really look at this as, let's take this quotient of just the numbers as one separate part of the problem. I'm going to take my quotient of m's as a separate part, and I still have that n to the 3rd. Remember we said we can always put that over 1, since there are no n terms in the denominator. Okay, now I'm simply going to divide my numerical part. 10 divided by 2 gives me 5. Using my quotient rule, I'm going to divide my m to the 8th divided by m to the 7th. Remember, that means we'll subtract our exponents. 8 minus 7 gives me m to the 1st. Remember, another way to write m to the 1st is just to write m. Either way is fine. And since we do not have the same base number for my n terms, there is nothing I can do there. So n to the 3rd stays n to the 3rd. I can either write my answer like this or like this. They both mean the same thing. All right, last but not least, let's make sure that we get that new rule into our notes. Quotient rule is the title of this, and the quotient rule states that to divide powers with the same base number, keep the base the same and subtract your exponents. Good luck, everyone.